Okay, so today what we're going to do is we're going to begin the geometry section of geometry and measurement. So we've learned how to measure things. We've learned all about units. We've learned how to convert between units, right? And if you need to go back and review some of that, you have all the videos, you have your notes, so make sure you remember to do a little revision there. But today what we're going to do is we're going to begin at the very basic idea, the very most basic geometric unit, which is a line. And the reason we're going to start there is because we're going to want to make sure that you have the right vocabulary and you're using the right terms and the ideas, right, to move forward. So here we go. Let's go to the book. So don't worry about that. So we're going to talk about points and lines. So the first definition that you need is a point. And a point is not really, well, it can be it is a physical thing, but it's really more of an idea. So it's simply a way to mark a location or position. Okay? So if you had a line, I can make a point anywhere along that line. Doesn't matter where it is. So I can make a point there, there, there. It doesn't make any difference. But I'm making that point to be able to go back and use it as a reference later. Right? So it's just a mark that allows you to define a specific location or position. All right? So that's the definition of a point. So, okay? And they don't have any size. So when you add a point to something, you're not adding any length or anything to it. So you wouldn't include a point, or a point's not going to make it any larger. Okay? All right. So you're going to see the points a lot as we go. So if you look at this example, here we have point A, point B, and point C. So each one of those dots is simply a point. But what I do want you to notice is the notation. They're labeled using what kind of letters?
Straight alphabet.
It's the alphabet, but they are what? It's just a position or a location. Capital letters. Yes? So do you see it's capital A, capital B, capital C, right? And we typically use capital letters to define those points. Shh, guys, because that way you know how important they are. So we give them the importance by labeling them with capital letters. Okay? So now we're going to talk about some lines. So we talked about what a point is, and we'll build on that in a moment. We're going to talk about some different lines. So a straight line is usually just called a line. You wouldn't need to say a straight line. If I say a line, then we typically think of a straight line. But there are, of course, lines that are not straight. Yeah? So we have curves. And points, and we can name a line by labeling some points on a line. So for example, this one has point A and point B, so we could call this line AB. It just means a straight line that passes through the points A and B. And a line is an infinite object. It has no starting point, no ending point. It goes forever in both directions. So if I just draw this, that is technically not a line. Right? Because it doesn't have the arrows on it saying that it goes infinitely in both directions. So if you see something like that has a definite start and stop, that is actually what's called a line segment. Even though we would colloquially call it a line. If somebody drew that, we would say that's a line. But a line is actually infinite. Okay? So this one is a line. This one is a line segment. And line segments are named by the points at which they begin and end. So that's line segment AB. Okay? And then finally, we have what's called a ray. And our ray starts at a point and then goes infinitely in one direction. And generally, we label another point on the ray so that you can name the line. Okay? So here, this is ray AB. Okay? Now, I want to point out some mathematical symbols. Look at the line. Again, what do we know about the line? Goes on infinitely in what? Both directions. There you go. Well, look at what they're called. See, here is the notation for this line AB. Notice that it's a simple bracket, right? Anytime you see that bracket, that means that it moves on. It doesn't have a stopping point, right? Okay. But for the line segment starts and stops at a specific point. Yes? And if you'll notice that, they're using these square brackets because there's a definite starting point and a definite ending point. A and B in this case represent the start and the end. So the square brackets are a more final form of it, right? They're harder, they're firmer, they're bigger. That just means this is where it stops. Yes? And so you see that notation. For array, it has a definite beginning point, and then it goes on infinitely in one direction. So there, it starts at A, and notice you get the square bracket. And you're getting the square bracket because it has a hard, firm ending, right? But then the other side just gets a plain bracket because it just goes on forever, right? So you need to be aware. So what if I drew these symbols? What does that mean?
No.
That it goes on forever in both directions. What if I drew this one?
It goes on one direction.
It goes on forever in one direction. Good. What if I do this one?
No.
So line segment stops firm at both sides, right? So this has a definite beginning and a definite end. Okay? And you're going to see this a lot as you move forward in mathematics, that different shapes of brackets do have different jobs. Okay? All right. Now, next thing. If three or more points lie on a straight line, they are called collinear. So the word collinear just means that they lie on a single straight line. Now, it's 3 points, 4 points, 20 points. It doesn't matter. Three or more points that lie on a straight line are said to be collinear. They all lie on the same line. So they're collinear. Okay? So good so far? Most of this is going to be about notation and definitions. So if you see here, point B, all of three of those lines go through point B. Okay? So that means that the lines are concurrent. Now again, you can put that in your notes. It's not going to... I've never seen anybody that question asked, but it's here, so we'll write it down. It's not going to kill us. Okay? Now... Oh, well then, sorry. I would be sad. I would be very sad. All right, here we go. Now we're going to talk about what are called parallel and intersecting lines. Now these things are critical. So pay attention because you need to understand what it means. Okay. Two straight lines in the same plane. Okay. Right? Can either be parallel or intersecting. You don't need to write that down, but hold on a minute. And we're going to talk about each one that's just a little further down. Okay? Parallel lines are lines which are at a fixed distance apart and never meet. Now, you can use that definition. I like to say that parallel lines, okay, are the same distance and never touch. Right? So they have to be maintaining the same distance apart all the time. Otherwise, if one of them slanted just slightly, somewhere in infinity, they would touch. Right?
Oh, yeah.
Okay? But if they're exactly the same distance apart all the time, they will never touch, no matter what happens. No matter how far you drew the line out, they would never touch. So, same distance, and they never touch. Okay? So here's an example of two lines that are parallel. Now, the only way you can really truly tell that they're parallel is to have a measurement or if they tell you that they're parallel. You are not allowed to just assume that they're parallel. Okay? Be careful with that. They may put just a tiny little bit of difference on it when you're measuring these. which would make them not parallel. So be careful. Now, so they're traveling. That means they're traveling on in that same pattern, so they're traveling parallel. All right? Okay. Now, so in the middle of the lines, it'll show parallel lines, right? And the arrowheads at the end just mean they're going on forever. But these little arrows mean that they're going on forever at the same distance apart. Therefore, they're parallel. Okay? All right. Let's look at the other ones. The intersecting lines. Well, we already know that an intersect means places where they what? Where they cross. Yeah, where they meet each other and cross. So here, these two lines intersect here at this point in the middle. This one goes on forever, this one goes on forever, and that's their point of intersection. And those two ideas are going to be really important to you as we move through this section. Okay? So parallel means they meet? Never. Intersect means they meet? Yes.
Yes.
Okay? All right. Good. Okay? All right. So here we go. Give 2 examples in the classroom of a point. So, what's a point in the classroom? Anybody got a point? The bottom left corner of the chalkboard. There you go. Anybody else want another point? Sure. Or the whiteboard. The top of the top corner of the cabinet. You bet. Right? Okay. Now, could the middle of this thing be a point? Absolutely. A point is simply a measurement or a destination. Okay? It can be anywhere along a straight line. Good job. Okay, guys? All right. What does a line segment mean?
That's A, that's B.
Right. So like here to the end of this desk to the end of this desk. This is a line segment because it has an end here and an end here. It's good job. Good. All right. How about a flat surface? A tabletop, right? That's called a plane. So a flat surface is a plane. Parallel lines. See any parallel lines in here? Sides of the desk, the top and bottom of the whiteboard. You bet. Lots of parallel lines in the world, right? Good. Okay. Okay. Shh, guys, come on. All right. Here we go. So, you're going to be working through some of those, talking through those. But before we do, what we want to do is we're going to now move on a little bit and talk about measuring and classifying angles. Now, yeah. So one of the biggest sections of this lesson is going to be about angles. So pay attention. Come on. All right. Whenever two lines meet, or edges meet, lines or edges. Edges is just another word for a line. Okay? And you see that in geometry we typically call them edges because they're the edge of the thing, but it's just a line. Yeah? So whenever two lines or edges meet, an angle is formed between them. So if you look here, these are actually two line segments that are meeting, do you agree? But they both meet at the same point, right? Okay? And so what happens is it forms an angle at that point where they meet. And so what we're going to do is we're going to learn a little bit about the protractor. Okay? Shh, guys. Now, to use a protractor, you're going to see that in the center, if you look at your protractor, in the middle on the bottom, there is a place where all of these lines meet. Now, it's not the bottom of the protractor. That is not a measuring line. That is just so you have a little more space there to make the protractor stronger. It is not the measuring line, right? So you just see the line right above it, though. You see a line that goes across. That is the baseline. That is the one you're going to use for measuring. So first, everybody look at your protractor. You see the difference? You don't measure from this bottom. You measure from the baseline. Right? What number does if you look on the outside, shh. If you look on the outside, the numbers here start at 0 and they go up to what? But if you look over here by 180, there's another place set of numbers that start with 0 and go in the other direction up to what? Okay? That allows you to measure in both directions, depending on which way the angle, which one makes it easier for you. Okay? Do you see the little bullseye thing there where where there's a little 2 sets of crosshairs? Right in the very center.
I haven't got that.
Okay. Well, some of you, yours doesn't have the whole thing, so it can be just a little line right in the center. Do you see that line? Right. Okay. Yeah, that little thing. There should be a line that crosses the baseline. That is where you're going to put your vertex. Okay. So look at this little line. This one doesn't. See, you have your baseline here, right? And then you have a line across like this. On this example in the book, guys, come on. On this example in the book, it's just this little pink line going down. But do you see that point right there where those 2 little lines meet? Could be a part line, or this one has a nice line that goes all the way through. That's where you're going to put the vertex of the angle that you're trying to measure. Make sense?
No.
And then the other line, one of the other lines, and it doesn't matter which one, will go along the baseline. And again, what's the baseline? The line at the bottom that goes all the way across, that runs parallel to the bottom of the protractor. Okay? All right? Okay. A couple of things before we start measuring, guys, is some notation for angle. Now, there's different notations for angle, and you're going to see they give you one here. But for this one particular angle, if you look at what they've measured, guys, here's the thing we're measuring. It goes from there and then goes up there. It starts at A, then goes to the vertex, which is at B, which is also the intersection, and then goes up to C. So we call this A, B, C. All angles have to have 3 parts. You have an end. All right, have to have 3 parts. You have an end to each line, or line segment in this case, and we have that vertex. And notice that the vertex letter is where in this grouping? At the end? In the middle. Why do you think it's important that piece go in the middle? Right? It's the middle part. Right? It's the vertex. The vertex of the name of the angle has to be in the middle. Okay? And then this notation uses a little hat on top of there so to represent angle. More commonly, you'll see this for angle. This, you see they drew a little picture of an angle. I drew a little picture of an angle, then put ABC. So that's read as angle ABC. Okay? But this book uses this notation instead. I don't care which one you use. But if you're measuring an angle, you better use some notation to represent. So can I just put ABC? No. I could put ABC with a little hat on it. Or I could put angle ABC. Either one of those, I don't care. I think the bottom one's easier, but I don't care. Makes no difference to me. Doesn't make any difference. They mean the same thing, right? Okay? So either one of them is fine. Okay? But this is called 3-point notation. You don't need to know the name, but you need to realize that to name an angle, you have to have 3 points. And which one has to be in the middle?
B.
Well, it's not always going to be B. It could be any letter. What's it called, though? The vertex. There you go. The vertex must be in the middle. Good. Okay? All right. There you go. So here, we have lots of lines meeting at the vertex D. Yes?
What do we name the angles?
Well, that's what we're talking about. Just depends on what angle you're measuring. So look at this one. If you're measuring the green one, here guys, come on, focus. If you're measuring the green one uses this line and this line, right? So we would call it angle, where does it start? A, then it goes to the vertex, which is labeled D, then it goes to this end, which is called B. So the green one would be angle ADB, right? So it's not always just alphabetical order, it's whatever one is the vertex goes in the middle. Okay? So
Why are you excluding C though?
because that's not the green angle.
Oh, C.
C is in the blue angle. Okay? So now let's do the blue angle.
BDC.
All right? If you look at the blue angle, it uses this line and this line. So it would be angle starting at B. What's its vertex?
BDC.
There you go. Okay? All right? Now, what if I wanted the angle using line A and C? What would it be? Angle A, D, C. Okay? So there are three different angles we could use out of this. We have these two smaller angles, and then we have that whole distance ignoring B. Okay? All right. It's good? Now, another thing that you must write down and remember is here. Look at what happens. We measured this, we didn't measure, we named the things on the inside, but notice that they have a line with an arrow here going around the vertex on the outside of the angles that we measured. Okay? This angle on the outside is something called the reflex. Okay? And since it uses line A and line C as its boundaries, its starting and stopping points, and it's still ADC, so it's the reflex of ADC. It's not ADC, okay? This is ADC, right? It's not ADC, but they're called the reflex of it. So the reflex is the outside. So for example, let's go back to those other angles that we're looking at. You're going to measure a lot of these. So here, this is the angle inside. So the reflex of this, would be the measurement. Sorry. So the reflex of this. Now I've got a line on there. Sorry. Would be there. Right? So be careful. If they ask you for the reflex angle, that doesn't mean that the angle inside. It means the angle on the outside. Okay? All right? And we'll learn how to measure those. Okay? Okay. This good? Again, mostly vocabulary so far, but we will do some measurement in just a second. Yes? Okay. Now, let's talk about some classifications of angles. You must know these definitions and know what they mean because you will be asked to draw these on the exam. Okay? So, the first one, or the test, the first one that we're going to talk about is called a revolution. This is classifying angles. And it's called a revolution because it starts and stops on the same line. So in other words, it goes around all the way 360 degrees. So a revolution is basically a drawing of a line segment, isn't it? There's only one line there. So if it's one line, then the end of it makes what's called a revolution. Okay? So what is a revolution all the way around? One revolution is 360 degrees. One revolution, full circle around. So it makes sense. Shh, guys, come on. Focus on what I'm doing right now. All right. The next angle we need to talk about is what's called a straight angle. And a straight angle is simply a straight line. Okay? Well, in this case, a line segment again. Notice that it's just a straight line. There's no other line intersecting it, but you do have a point right here in the center. So we're measuring from this arm to this one. And the measure of a straight angle is always the same. It's always 180 degrees. Or in other words, half of a circle. Like your protractor. So that's what's called a straight angle. The next one you've seen before is something called a right angle. Now, a right angle is an angle that makes a perfect corner, and so a right angle is always exactly 90 degrees. So like where the floor and the wall meet, right? At a right angle. Now, you may not always see the measurement 90 degrees, but if you look at this angle, what have they done here that tells you that this is a right angle? Yeah, they drew a little square in it, right? Because a square is made up of 4 right angles. A square will only fit into a right angle. Okay? So the angles of a square are all right angles. So if you draw that little square. So sometimes you could see this and it could say that the measurement is 90 degrees, which we know it's a right angle. But more often than that, they don't bother. They just draw that little square in the angle, which indicates that it's 90 degrees. And therefore, what kind of angle? A right angle. So, revolution means all the way around. Straight angle means straight line, so half a way around. Okay? And a right angle is how many degrees? 90. The others that we need to talk about are here. We have an acute angle. Guys, focus. An acute angle is between 0 and 90 degrees. So think about this. So it's smaller than a right angle, right? So it's a cute little angle.
Oh, that's so cute.
Does that make sense? So it's a cute little angle. Okay. Between 0 and what?
99.
Can't be 90. Why?
89.
So yeah, it's up to 90. So it can't be 90 because if it was 90, it would be a right angle, right? But it's between 0 and 90. Right? Those are the boundary points. Okay? The next one is what's called an obtuse angle, and it's between 90 and 180. So not a straight line, but bigger than a right angle. Obtuse. Obese. Big. Right? Ob always means big. So that means bigger than 90 degrees. Pardon? Obtuse, I don't know what the obtuse part is. But anytime you see ob, you're talking about a stretching or making it bigger. Okay? All right? So, like an oblong is a stretching of a circle, right? That kind of idea. Okay? So obtuse. So you have what? A cute little angle, which is what? Less than what?
90.
Obtuse. More than 90, but less than 180. Good. And then anything bigger than, what's that called? A straight angle is 180 and 360, and that is the definition of a what? Reflex angle. There you go. Reflex is just the other side. Okay? All right? Shh. Ladies, you're messing up my recording, kids. All right. Now, you must know all of these. You will be asked to define what kind of angle is this, and then you will be asked to measure it. So you must know the names. Okay? Right? A couple weeks. Okay? All right. Got them? So there we go. So what we're going to do today is you're going to do for homework, we're going to go back to the lines a little bit. You're going to do exercise 2A. All of them. Okay? And that starts on page... Sorry.